How are you, everybody who is watching this fantastic video? I'm very happy to have you in this session. My name is Olenjolai single from beautiful countries that called Tanzania. It's one of the African continents, and I have a good news for you today concerning about the engineering and scientific undergraduate education. Well, I will take this opportunity to welcome you into one of our online institutions that's called Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. So you have to make sure that here you add the word or the letter M. Check at the name of my helper. Okay, M. So just you add it there. And then simultaneously, I would like to welcome you into one of our YouTube channels that's called the Online Undergrad Institute of Tanzania in square bracket OLENJOLAIM. So undergrad is abbreviations of the word undergraduate. Institute is abbreviations of the two words Polytechnic Institute. So the next questions in your mind is what the visions of Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. That's very fantastic question, and it's very good questions. It's a very nice question. So the vision that we have in Online Undergraduate Polytechnic Institute of Tanzania is this. We have an assignment to teach. So we have an assignment to teach and train some undergraduate students who are ready to take the classroom instructions, whether formal or informal, in engineering programs or in science programs, and combine the knowledge that extracted from the classroom instructions and the knowledge and wisdom that we are teaching. So we have, as I said, that the main objective or the main goal of these programs or that we have in Online Undergraduate Polytechnic Institute of Tanzania is to teach our students on how to solve real life problems. So that's the main vision that we have, and that's the main goals that we have, and we have missions also. Well, so whether you have been in deep love with mathematics, or we have been, maybe you didn't love it for the rest of your life, get prepared that through these programs, believe me that you are going to be transformed from hating mathematics into the great love of mathematics. So we have so many departments in our Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM, and we'd like to welcome you into one of the departments that called the High Engineering and Scientific Mathematics. So the modules that we have today, or the course that we have, is called Calculus, and we have chapter 5, which is Fourier series, and this is lecture 4, solving problems of Fourier series over the period 2 pi. And hence these contents are for the class of NTA level 7s or first year undergraduate students, or same as called the PNG students. Again, so we have our online library where that we are equipping our students with relevant materials. For example, this is the scientific calculator, which is called the Casio function 981 MS. We are also providing, so we are distributing this scientific calculator to our students with a very affordable price, because we want to equip you so that you can order in any regions of 31 regions of Tanzania. In any regions in Tanzania, you can order it and you can ship it to you. So again, we like to ask you that in case that maybe right now or later on, or in the middle of these sessions, or at the end of these sessions, or maybe that while you are not watching this program, you can offer our card, the free willing sense givings of any amount in order to support, and that free willing sense giving will be used to just support the running cost for this program. So you can offer it through this telephone number 0759745331. So we are in lecture 4 of solving problems of Fourier series. This is chapter 5 Fourier series, and we are teaching you solving problems of Fourier series over the periods 2 pi. So for you to get notification, just look on your right hand side to get the information once we'll be uploading the lecture 5 of Fourier series. Just click this button of subscribe, and then the bell will appear. Just click this bell, and then this is the options. Choose the options of all. Then you'll get notifications once we upload any video, or we add any video into our YouTube channel. So let us go into the today's sessions. In today's session, in this lecture 4, this is the continuations of lecture 3. Remember that lecture 4, it's a continuations of lecture 3. So lecture 4 is continuation of what? Of lecture 3. So we have to finish on what we covered in lecture 3 and give you some few points, and then afterward, Dems will give you the homework. So if you remember that in lecture 3, we'll be given the functions, which was just to remind you that the function will be given the function which is f of x. This is equal to k, and then from negative pi less than or equal to x less than or equal to 0. And then it is negative k when we have 0 less than x less than pi, less than or equal to pi, something like this. Okay, so that's what we have there. And then the questions ask us to find, first of all, to sketch, secondly, to find the Fourier coefficient. So just to remind you, because you have to start there, the Fourier coefficients, we found all the 3 Fourier coefficients. The first Fourier coefficient A0 is equal to 0. The second Fourier coefficient AN is equal to 0. The third Fourier coefficient, which is BN, was not equal to 0. Okay? So this is quick example 3. It was example 3. If you do remember that this was example 3. So we are still solving example 3, Roman 1. This is all about Roman 2. Roman 1 was sketching that we discussed and covered. So Roman 2, so we had the Fourier coefficient Bn. Okay, the Fourier coefficient Bn. So the Fourier coefficient Bn was 2k over pi n over pi n, and then so we have 1 minus cos of n pi. Yes, 1 minus cos of n pi. So let us go to example solution of example 3, Roman 3. So obtain what? So if you remember that, obtain Fourier series of 40 of the given function f of x, which have been given there. How can you find it? That's a good question. So one of the steps, we say that, okay, to obtain this one, let's just see the first step, recall the general formula of Fourier series. The formula of Fourier series is what? It is given as f of x is equal to an. Then we have summation of n is equal to 1 to infinity. So this is an cosine of nx, then plus what? bn sine of nx. Okay? So this is the Fourier coefficient, or the general formula of Fourier coefficient. So if you write, we want to write in the sigma notations, we can say that f of x is equal to the Fourier, this is a0, excuse me, a0 is 0 plus what? Sigma notation from n is equal to 1 to infinity, an is 0, so it will make the cosine this part to be 0 plus what? bn sine of nx. Okay, so simply it means generally we say that f of x is equal to what? Summation of n is equal to 1 to infinity, then bn. What is bn? So bn is equal to 2k over pi n, and then so you have what? You have 1 minus cos of n pi, okay? Yeah, so this is the general function. And hence you have what now? This is is incomplete, and sine of nx. So the general Fourier series, we can say in sigma notation, is this one. But this is not a preferred form of present the Fourier series. We have a preferred. This is not, it's a series, but written in the shorthand, which is in sigma notation. Okay, the main concept that we have to teach you are the students, how you can write the Fourier series, which is open. We say that in long form. The Fourier series which contain the first term, second term, third term, fourth term, fifth term, sixth term, that's what we have to teach you. And that will be the best way of writing the Fourier series. So we go for the second step. So the second step, we say that just obtain, we say that to obtain what? So we say that from Bn is equal to 2 pi, 2k, 2 times k over pi n, 1 minus cos of n pi, like this one. Then we say that find first, second, third, fourth, fifth, sixth, seventh terms. So how do we find? So for the first term, we say that when n is equal to 1. So when n is equal to 1, we have b1. b1 is equal to 2k, which we don't know its value, pi times 1. Then we have what? Cos, we have 1 minus cosine, but n is equal to 1, so cosine of pi. So I say that cos of pi, remember that pi is equal to 120 degrees. So b1, this is equal to 2k over half. And here we have 1 minus negative 1. Because cos of pi, it is negative 1. Okay? It is negative 1. So negative 1 times this negative 1, or 1 minus negative 1 is equal to 2. So this will make 4k over pi. So that's the first term, Pn. So then we go for the second term, when n is equal to 2. Remember that this is odd. Then this is even. N is equal to 2, it's even term. So then we find b2. b2 is equal to what? Is equal to 2k over 2 pi. Then you have 1 minus cosine of what? Of 2 pi. Cos of 2 pi, it's 1. 1 minus 1 is 0. So b2 is equal to 0. So b2 is equal to 0. Why? Because cosine of 2 pi is 0. So then we are going to find the third component of third term. So the component of the third term. So you have to find out when the value of b, when n is equal to 3, which is odd term. You note something here which is common in most of the Fourier problems. So we are looking for b3. This is equal to twice k over 3 pi. Then this is 1 minus cos of 3 pi. So this will make what? It will make 2k over 3 pi. Here we have 1 minus negative 1, because cos of 3 pi, which is equivalent to 270 degrees, is negative 1. So then we say that b3, this is equal to what? Is equal to twice k over 3 pi. Then if you substitute that is twice, so it's equal to 6k over 3 pi. Is it? That's b3. 6 pi or 4 pi, excuse me, 4k. That's basically it. So then we go for the even. So when n is equal to 4, this is even. Okay, when n is equal to 4, we are looking for b4. This is equal to 2 pi over 4 pi, then 1 minus cos of 4 pi. This is equal to what? Equal to pi. No, this is k, 2k. This is equal to k over what? K over 2 pi multiplied by 0. The answer is equal to 0. So so then we go for when n is equal to 5. So when n is equal to 5, we find that b5, this is equal to twice k over 5 pi. Then we have cosine, we have 1 minus cosine of 5 pi. So this is -1, 1 minus -1 is 2, so the answer is equal to 4k over 5 pi. So this is for odd. So you can notice that for all, when the value of n is odd term, then the value of bn is not equal to 0. But when the value of n is equal to even, or is even, then the value of bn is what? 0. So this we say that, so you say that in not before, if n is equal to odd term or odd term, then bn is not equal to 0. If n is even, then bn this is equal to 0. So for all. So then right now we say that there's no need for us to find for what. This means that when n is equal to even, it means 2, 4, 6, 8, etc. So right now we should not waste our time. We have to find for when n is equal to 7. So b7. So b7 for this case it will be twice k over 7 pi times 2. So the answer is equal to 4k over 7 pi. So now we have our terms. So we go for the third step. The third step, we say that find, okay, so we say that, okay, so that is from that one. So we say from the Fourier function of f of x, for instance, is equal to sigma of n is equal to 1 to infinity, bn sine of nx, okay, sine of nx. So we say that find the component of what? Of sine nx. So to find them, say that when n is equal to 1, then we are going to have sine of x. when n is equal to 2, which is not there, we have sine of 2x. Then we say that when n is equal to 3, we have sine of 3x. When n is equal to 4, we have sine of 4x. When n is equal to 5, always we have sine of 5x. This is the foundations of solving all the Fourier problems. If n is equal to 60, this is sine of n 6x. If n is equal to 7, then we are going to have sine of 7x, etc., 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 to n and here to n. Okay. So then our object now to write the Fourier series. So we say that f of x, this is equal to what? Summation from n is equal to 1 to what? To infinity. So let's say bn sine of nx, particularly, this is equal to what? b1 is equal to what? 2k over pi. Then sine of x. When n is equal to 1, when n is equal to 2, we have the 2k or 4k. 2k, 4k, choose me. This is 4k. When n is equal to 2, we had 0, plus when n is equal to 3, we had 4k over 3 pi, then sine of 3x, plus when n is equal to 4, bn is equal to 0, so plus what? 4k over 4 pi sine of 5x. Sine of 5x. Then plus what? When n is equal to 6 to 0, plus what? 4k over 7 pi, then sine of 7x plus h. Okay? So this is the kind of a series that we have. So now we say that f of x, which you can write in the shorthand at n is equal to 1 to infinity. bn is what? 2k over n pi. Then 1 minus cosine of nx. Okay, then sine of what? Sine of nx. This is equal to what? 4k it is common and pi it is common. So this is equal to 4k over pi. Then we have what? Sine of x plus 1 over 3 sine of 3x. Then plus 1 over 5 sine of 5x. Then plus 1 over 7 sine of 7x plus h dash. That's the Fourier series, and that's what we've been looking for. Okay, believe that you're enjoying the beauty of Fourier series the rest of your life. Okay, so therefore, Fourier series of f of x is what? Is given as what? 4k over pi. Then you have sine of x plus sine of 3x over 3 plus sine of 5x over 5 plus sine of 7x over 7 plus dash 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 is the response. And then you finish to solve example 3. Right? Interesting. So this is the end of solutions of example 3. So you see, it's interesting, but actually that you have to do a hard work. You have to do too much work. Then we have example 4, which is related to example 3. Example 4. Say that if the value of k is equal to 1 in example 3 above. Example 3 above. Okay? Then deduce a series. Then deduce a series for pi for x is equal to pi over 4 at the point for pi over 4. For pi over 4 at point x is equal to pi over 2. So this is an example relating to the previous example. This is an example relating to the previous example. Okay. So if the value of k is equal to 1 in example 3 above, then deduce the series for pi is equal to 4 at the point x is equal to pi over 2. So where the series is the series. Okay? So solution. The first stage of the question, you have to recall the Fourier series of example 3. So the Fourier series of example 3 is f of x is equal to 4k over pi. Then we have what? Sine of x plus sine of 3x over 3 plus sine of 5x over 5 plus sine of 7x over 7 plus dash dash dash. So the question now asks you that if the value of k, okay, so the value of k is equal to 1 in examples 3 above, then deduce a series for pi over 4 at the point x is equal to this one. So suppose that this is our first equation. So then we say that substitute the value of k. This is simple question. K is equal to 1 and pi and x is equal to pi over 2 in equation 1 above. So this is the second step. This is the second step. Okay? So to do this, we say that remember f of k is equal to what? So we say that f of k is equal f of x. So f of x was k, if you do remember. k or negative k, right? So we consider for the positive k, right? So remember that f of x is equal to k, which is equal to 1, and this is equal to 4 times 1, which is the value of k, over pi. Then here we have what? Sine of pi over 2, means sine of 90, plus what? Sine of 3 pi over 2 over 3, plus what? Sine of 5 pi over 2, then divided by what? By 5, then plus what? Sine of 7 pi over 2 over 7, plus dash dash dash. Okay. Okay. So then we have 1 is equal to what? 4 over pi. Then sine of 90. If you forgot, use the scientific calculator. Sine of 90 is 1. Then 3 times 1, 8 over 2. It's 270. Sine of 370. It's negative 1. Then sine of 5 times 180 was 5 times 90, which is what? 450. It's positive 1. Sine of 7 times 90, which is 360, 330. So sine is negative. So it's negative 1 over 7 plus dash. So simply 1 is equal to 4 over pi. Here 1 minus 1 over 3 is 1 over 5 minus 1 over 7 plus dash dash, like this. So you have to refer the questions. The questions ask us if the value of k is equal to 1 in example 3 above, then deduce a series for pi over 4. So let us make pi over 4 the subject. So suppose that this is equation what? Suppose that this is question 3, question 2. You have dot, 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 dot. This is question 2. So then we have to go for the third step. Third step, we have to make pi over 4 the subject of equation 2 above. So you have 1, this is equal to 4 over pi, 1 minus 1/3 plus 1 over 5 plus 1 over 7 plus dash dash dash. So we multiply by pi over 4 and also multiply by pi over 4. So you have 1 multiplied by pi over 4. Okay? So this side we have pi over 4. This is equal to what? This is equal to 1 and 1/3 plus 1 over 5 plus, this is minus, minus 1 over 7 plus dash dash dash. So this is the series that reduce the series. This is what you've been asked. Okay? So that's what you have been asked to deduce. Deduce what is the series for pi over 4. Okay? Okay, so this is what you've been asked in example 4. that if the value of k is equal to 1, it means the value of the functions is equal to 1. We know the value of the function right now. And then that in example 3 above. Then deduce the series for pi over 4 at the point x is equal to pi over 2. So the first step we have to recall just as the way that I taught you. So this the point right now that we've reduced the series that which is pi over 4 is equal to 1 minus 1 over 3 plus 1 over 5 plus 1 over 7 plus dash 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 dash. Yes, because to be plus. So but this is minus, excuse me. This is minus. So then after covering that, the next step right now, I want to give you the homework because in lecture 3, I didn't give you the homework, so in lecture 4, I have to give you homework so that you may be active in the process of learning, right? Okay. So this is example 5. So example 5, and I have to refer the T final exam, question 1, Roman, question 1, Roman A. So question 1, Roman A, and then Roman 2. Very simple question. You have to kick it quickly as well as possible. Okay, so the question states that if the Fourier coefficient Bn, this is equal to negative 2 over n, then negative 1 over n, write the Fourier series. Write the Fourier series. So this is, if you manage to do that, you'll be given 3 marks. So it's just a testing of your understanding on what we've discovered, on what we've discussed. Why? Because if the Fourier coefficient Bn, how many Fourier coefficients I told you there is? A0, An, Bn. So you'll be given 1. Don't worry about A0 and An in this case. If the Fourier coefficient Bn is equal to negative 2 over n, then open bracket negative 1 power n. Write the Fourier series. So don't worry about A0, don't worry about the B, the A0, the N0, and An. Okay, so you have to just write the Fourier series by this one. So you just do as how we have used the Bn, which is equal to 2k over pi n, open bracket to 1 minus cos of n pi, to find the Fourier series. So it means that for this case, you can either assume A0 is equal to 0 and An is equal to 0. So I'm trying to help you so that you cannot get challenges along the process of solving this problem. Because I know that the Fourier series in your mind is still something, it's still a new concept. You've never discussed about Fourier series in advanced educations. You have never discussed Fourier series in ordinary diploma based engineering and mathematics. So this is the first time for you. That's why that we have to make sure that we take you step to step. But later on, we'll just give you a question, and then you have to try to think yourself beyond the concept that we've covered. So this is the end of lecture 4. I invite you to join me in the next lecture, which will be lecture 5. And I will be solving now a kind of another periodic functions. The Fourier series I'll be solving I'll be finding the Fourier series of the trigonometrical periodic function, which is the sine. And you have to make sure that you review the concepts of the factor formula for the that we taught you in trigonometry during your advanced educations or during your ordinary diploma in basic engineering and scientific mathematics. case that maybe you forgot, you have to make sure that you visit our other online institutions that call the online Diploma Polytechnic Institute of Tanzania, square bracket Olenjolai, or or we have also a YouTube channel called Online Diploma Poly Institute of Tanzania, square bracket Olenjolai. So there you will learn a lot about trigonometry as just the second module for the first diploma, for the first year ordinary diploma students. But in case you forgot it all, I will try to help you just to go quickly to remind you about few factor formulas, 2 factor formulas that we need to use in order to solve the next problem, which will be example 6. And then from there, I will take you into the next subtopic. It means that I will be teaching Fourier series of non-periodic functions. That will be the next topic. So in order for you to stay connected, and in case that we update or we upload a new session or a new lecture, which will be lecture 5. So in case you want to be notified automatically, remember to subscribe into our channel. Remember to share these contents with other students. Remember to ask your questions in the comment section. And remember to submit. So submit your homework. So submit your homework is great. This is homework 4. This is homework 4. Submit homework 4. Okay, submit homework 4 in comment section of this video. So submit it in comment section. Okay, then we review, and finally you'll enjoy your life. So remember also to share these contents with others, as I said, and then make sure that you ask questions in the comment sections in case you have any difficulties in Fourier series. But also you have to make sure that you can use the comment section to tell us you enjoyed this content from which institution, how did you find these programs, is it helpful for you? So tell us in the comment section, please. And also use the comment section for the group discussions. Okay, again, in case you feel from your heart, because this is the work of heart for myself, right, that you want to offer God your free willing thanksgiving for this program, then you have to make sure that you send your free willing thanksgiving through this telephone number 0759745331, and then your free willing thanksgiving will be received and be used intensively in order to make sure that so many lectures or so many videos of undergraduate, higher engineering, and scientific mathematics to be in air. Okay, so may God bless you. Firstly, I thank God who have created me in His own image and likeness, and I thank God who have given you opportunity to be with me, and I thank God also who is going to give us another opportunity to meet in lecture 5. And I thank God who is in charge and who is the sponsor of this, who is the sponsor of Online Undergraduate Polytechnic Institute of Tanzania, square bracket Olenjolai. So may God bless you until we meet in the next session. So stay tuned, stay enjoy the beauty of mathematics undergraduate.